Hi everybody, welcome to my mini lecture on break-even analysis. This type of analysis is so important. You are going to come across the need to do this at some point. Whether you're producing a product or a service, at some point you're going to have two different options. One's going to be more expensive but might have a lower variable cost, and you're going to have to try to understand at what point do you make the decision to say, yeah, you know what, I think we're going to sell enough that we should make that investment because it's going to be more beneficial and financially prudent in the long run. So in order to walk us through this example, I'm going to be using Anheuser-Busch as an example. So for those of you that like to drink multi-packs, this has really been a recent evolution in terms of having these multi-packs where you have different varieties of beverages in the same case. So when Anheuser-Busch first started to introduce the multi-packs, this is about a decade ago, you would think that it would be, relatively easy. They would be able to figure it out, some way to automate it, but they couldn't. So originally, when they knew that multi-packs were starting to become more desirable, they wanted to make this happen, but they didn't have the equipment set up at the time. So in the Baldwinsville plant in upstate New York, they had people physically picking up bottles from one line and putting them into a case 2x2 or 3x3, whatever the multi-pack called for. As you can imagine, that scenario was relatively inexpensive. It didn't require any major capital expenditure, but it did have a really high variable cost because you were having a ton of labor going into creating these multi-packs. So in that scenario, which we're going to refer to as option one, just adding staff to be able to make this happen, the fixed cost was only about $50,000. They just had to move a few things around, but the variable cost was actually pretty high. So it was about $2.50 per case. So that was, again, that included primarily the labor that went into making this happen. Now, actually in Anheuser-Busch, I think that this is interesting. They had one of their engineers design a robot, actually come up with a design. It was something that they didn't outsource, but they were able to source within house the expertise, the brain power to create the automation to be able to have a robot that would pick up and move these different beverages from the line into the multi-pack. So this robot was really cool. They were trying to determine whether or not they were going to move forward with it. And so they anticipated a total expenditure upfront fixed cost to be able to put into R&D to make this happen of about $10 million. That's how much it would cost to design, develop, manufacture, and actually implement this robot. So while it was a $10 million capital expenditure and investment upfront, it drastically lowered the variable cost for the actual cases. So it reduced the variable cost to about 75 cents per case. Now, the problem here was that they didn't really make modifications to the line. So their capacity was constrained by the volume of the bottles on the line coming in. So they knew they needed to make some additional modifications to be able to increase the volume that was actually going through this robot and that would bring in bottles coming from different manufacturing lines, all converging in the same place and utilizing the robot. In order to go that extra step, they would require an additional investment of about $8 million for a total expenditure of about $18 million for a fixed cost. But again, since the volume was going to be higher, it would further reduce that variable cost to about 25 cents per case. So our job too now is we need to try to evaluate what does the demand have to be in order for each one of these options to make sense. And if we know that multi-packs are going to fly off the shelves and exceed our expectations and we're going to sell 20 million over the next 3 years, which one of these do we want to invest in? Is the $18 million going to be too expensive? Does that financially make sense? We are going to use the break-even analysis to find out. So the first thing we do is we set option one equal to option two. That's going to tell us the break-even point between those two, or basically what's that point where it makes sense to make that additional incremental investment in capital expenditures to go into option two and invest in the robot. So the way we do that, our first step is going to be setting these two equations equal to each other. So in the first case, option one, our variable cost is $2.50 per case. So we're going to include our variable here, X. We're going to add on the fixed cost of $50,000. Again, that's for the manual approach to just adding labor to solve the multi-pack problem. Option 2, use of the robot, has a variable cost of 75 cents plus a fixed cost of $10 million. And here we're just going to go through and we're going to solve for X. So we are going to, let's bring our 75 cents over here, minus 0.75. That's going to give us $1.75 multiplied by X. And we're going to minus our $50,000 here, minus $50,000. And that is going to give us $9,950,000 divided by 1.75, divided by 1.75. And our X is going to be $5,685,714. So basically, if we know that we're going to sell more than 5.6 million multi-packs, and it doesn't have to be within a year, it's just over time. If we know we're going to exceed that with our demand, then we should definitely make the investment in the R&D and the production of that robot to be able to support us to create and automate the multi-pack line. But again, if we know that we have some constraints in terms of the line and the total volume that can be routed through that robot, if we want to see about making modifications to additional lines to make sure that we're having all of those different production lines merged together and make use of this robot, let's see what we would have to be able to sell in order for that to make sense. So to do that, we're going to set option 2 equal to option 3. So here we have our, for again, option 2, a variable cost of 75 cents per case, fixed cost of $10 million, equal to option 3, a fixed cost of 25 cents, and, or I'm sorry, variable cost of 25 cents and a fixed cost of 18 million. So here we're gonna minus the 0.25x, minus 0.25x. That is going to be 50 cents. And then we're going to minus the 10 million here, minus 10 million here. That's going to give us 8 million. Divided by 0.5, divided by 0.5. Our break-even point here is going to be divided by 0.5, 16 million. I should have known that. 16 million. So if we know, if we're Anheuser-Busch, who's owned by InBev, if we know that multi-packs are the thing, they're flying off the shelves, and we do our forecasting accurately enough, and we predict that our demand is going to exceed 16 million cases of these multi-packs, then absolutely makes sense to invest in option 3. Even though we're going to sink a lot of money up front into those capital expenditures, that 18 million, it's going to pay back in the long run because our variable costs are going to be lower. If you have any questions, as always, please feel free to reach out.